Okay, we'll go into problem number 4. And again, I won't read through it. We're trying to find out where the particle is at rest. And when it says to justify it, this is what I usually do. I start my justification at the beginning. The particle is at rest when velocity is equal to 0. So I set it up, and that tells me what it is that I have to do and what it is that I have to find. I need to find where x prime of t is equal to 0. So I need to find the first derivative. And this is a product rule with a chain rule. Now you could multiply things out. I'm going to suggest that it probably will take longer to do that, but this is the way I would do it. We're going to do 1d2. So 1d2 is going to be 2t minus 1 times the derivative of t minus 1 squared, which is 2 times t minus 1 to the first times 1, since the derivative of the inside function is 1. So that's 1d2 plus 2, which is t minus 1 squared, d1, which is just 2. Alright, before I would do anything else, again, our goal is to find out where this is 0, so I'm thinking factoring. And both of these terms have a t minus 1 factor, so that's the first thing that I'm going to factor out. And on the left-hand term, that leaves me 2 times 2t minus 1, which is 4t minus 2. And on the right-hand term, I've taken out 1t minus 1, so I still have a t minus 1, and that's times 2, so that's 2t minus 2. And then this is going to work out pretty well. It gives me t minus 1 times 6t minus 4. And I could have factored out an additional 2 at the beginning, that's true. And that leaves me with the, we're trying to find out where the particle is at rest. That would be at t equals 1 and t equals 2/3. So now I'm going to go back up to the justification that I started, and I complete my sentence. At rest, particle is at rest when velocity is 0, that is when t is equal to 1 and t is equal to 2/3. So I have my justification and I have all my work there. I've done everything, and I'm going to go on to B. Now I'm looking for some room, so I'll work up on the top here. And I start my justification. The particle moves left when the velocity is less than 0 or negative. And so that tells me what I have to do. I have to set the velocity, I have to take the velocity and find out where it's negative. Now in part A, I've already done the factoring on the velocity, and I found my critical numbers. So I set up my sign chart. I picked some values. I could pick t is equal to 0. I'll use 1/2 and 3/4 and 2 in there. Remember that it's easiest if I go back to the factored form. And I'm just going to plug in 1/2. T minus 1/2 minus 1 is negative. 3/2 minus 2 is also negative. I have negative times negative. Negative is positive. I'm going to do the same thing with 3/4. 3/4 minus 1 is negative, but 9/4 is more than 2, so that'll be positive. Negative times positive is negative. And I do the same thing with 2. 2 minus 1 is positive. 6 minus 2 is positive. And positive times positive is positive. Now I'm ready to complete my sentence that I started at the top. That is, x must be greater than 2/3 and less than 1. Now I can't just use the sign chart there. On the AP test, they will not take the sign chart as your answer there. So you still have to state it clearly. Moves left when v of t is less than 0, that is, x is greater than 2/3, less than 1. I've done my justification in a succinct way, and I've given my answer all together there. And so that's part B. We want to find out what time in the interval between 2/3 and 1 is the particle moving most rapidly. So what we really need is the derivative of velocity to find out where it's changing at its greatest rate. So we say we want to find the maximum absolute value of velocity. We don't have a closed interval here. Well, we do have a closed interval between 2/3 and 1. We know that the derivative is 0 at those endpoints. We know that velocity is 0 at those endpoints. Now for the second derivative, I'm going to quickly use a product rule. That's 1 d2 is 3, and 2 d1 is just a 2. And simplifying all that gives me 6t minus t plus 6t minus 4 is just 12t minus 10, or 2 times 6t minus 5. And since that's the only minimum or maximum point, that has to be the greatest maximum value, greatest absolute value of velocity.